Okay, students, as I told you that the name of our chapter, our topic is that is Avogadro concept, the acids, bases, and salts. This is the chapter name. The unit is 1 and lecture is 7. Okay, so this is some of the course objectives I have given here, and also some of the prerequisite knowledge. So our paper name is Basic Chemistry, which is for all branches of the Diploma Engineering and Technology, and the contact hour is 13. Now, what is the prerequisite knowledge? Before knowing this basic chemistry, you should have the knowledge of chemistry up to 12 standard. Okay, and you should have the visualization and analytical approach towards the subject that is necessary for completion of this completion of this course. Now, what is the course objective? The course objective is to apply the knowledge of chemical and physical property and processes in engineering field. And also the content of this subject provides the knowledge of engineering applications of different compounds. These are the some of the course outcome that I have given for our course. That is, the you can after completion of this course, you can draw the atomic structure of different elements. You can represent the formation of molecules schematically. You can describe the mechanism of electrolysis. You can identify the properties of metals and alloys related to the engineering applications. You can identify the properties of non-metallic metals, which is related to the engineering applications. Okay, different engineering applications in different industrial field. And also you can acquire the knowledge of softening of water. If we have the hard water, we have to soften that water, and after that we can use that water in different industries. And also you can know the basic organic compounds which is applicable to the industry. So these are the some of the course outcome that we have for our course. Yeah, this is the lecture plan that we have. Yeah, so this is the today's objective of our class. So today we will discuss about the Avogadro number. I will give you some of the idea about the Avogadro number and what is the importance of this Avogadro number, that also we will discuss. Next we will discuss about the mole concept. What do you mean by mole? 1 mole of the substance. What do you mean by molarity? So all this we will discuss. Simple some of the numerical problems also we will discuss, and we will see some of the quick view of the Rutherford atomic model and also Bohr's atomic model. As this is this chapter is related to the atoms and molecules, so first of all you should know some of the atomic models that Rutherford had suggested and Bohr has suggested. Okay, so these are the some of the objectives of our today's class. Yeah, so first of all, you should know what is matter. Okay, the matter, how you can define the matter. The matter is defined as anything that occupies spaces and possesses mass. One can feel the matter by our senses. Some example like air, water, chair, glass, etc. Okay, and generally, matters are divided into two groups. One is physical classification, which is based on the states of matter, and some of the chemical classification of matters we have, which is based on the chemical nature, chemical properties. Okay, so physical classification, which is based on the state of the matter, and chemical classification, which is based on the chemical properties, the chemical nature of the material. Yeah, so This is a physical classification. Now, physical classification, generally there are four states of matter that we know, that is the solid, liquid, gaseous phase and the plasma state. So these are the four states of the matter that we have. Matter can exist mainly three different physical state, and plasma state is the fourth state of matter. Solid, some solid, liquid, as I told you, solid, liquid, gas and the plasma state. These are the four states of matter that we have. So substances which possess definite shape and definite volume are called the solid. In solid, the substances, the atoms are compact, okay, and they're holding through a very strong covalent bond, okay. So like sugar, wood, pen, pencil, chair, etc. These are all solid. Now, liquid substances which does not possess definite shape but have definite volume are called liquid. What will happen for the liquid? The intermolecular attraction force is less to some extent than the solid materials, okay. So that is why they don't have definite shape but have a definite volume, of course. Like some example, you know already, milk, water, oil, tea, these are the examples, okay. And gaseous substances which possess neither definite shape nor the definite volume are called the gaseous system, gaseous state of the matter. Generally, for gaseous particles, what will happen? The intermolecular attraction force is totally lost, okay. So that is why they don't have definite shape and the definite volume. Okay, some examples of gases are air, hydrogen, nitrogen, okay. And the fourth one is a plasma state, that is the state of the matter which is regarded as a special circumstances. For special plasma state, we should have some of the special circumstances. For example, the matter in the sun and fluorescent tube is in the plasma state. Okay. So now we will discuss about the chemical classification of the matter. So chemical classification, matter can be divided into two categories. One is element and one is mixture. So what are the element? That is the pure substances which is made up of one kind of atoms is called the elements, like hydrogen, oxygen atom, sodium, nitrogen atom, iron atom, silver atom. So these are all the elements are called the pure substances, and that is called by the elements. And mixture is defined as a substance that is formed by mixing of, excuse me, two or more than two more substances, like hydrogen plus oxygen, it will form the water. So that is obviously the mixture, okay. Next, iron plus oxygen, it will form the iron oxide. So obviously this is a mixture of the compounds. So these are the two substances, these are the two divisions of the matter based on the chemical properties, chemical nature, okay. Pure substances, the substances made up of only one type of matter or have uniform chemical composition and or have identical properties throughout. So pure substances are further classified into pure substances, that is classified into two, that is element and mixture. Already I have told you. Yeah, so now we will see what are the differences between compounds and mixtures we have. The compounds, that is the constituents present in fixed ratio by mass, and for the mixture, the constituents are present in any ratio by mass or volume. It is always homogeneous. The compounds are always homogeneous, but it may be or may not be homogeneous. Its properties are different from the properties of its constituent elements, and its properties are entirely different from the properties of its constituent substances. The compound is characterized by sharp melting point and boiling point, okay, and it has no sharp melting point and boiling point. So a compound is formed as a result of chemical change associated with a definite amount of energy change, that is heat evolved or absorbed. And this is for the, yeah, this is for the mixture actually, because we don't have space here, so that's why I have written here. A mixture is formed as a result of physical change which involves no or low amount of energy change, that is heat evolved or absorbed, okay. So these are the some of the differences between the compounds and the mixtures that we have. Okay, now we will see what are the concept, how you can define the mole, how you can define the Avogadro constant. Okay, the number of moles in a substance in a system can be determined using the atomic mass of an element, which can be found on the periodic table. This mass is usually an average of the abundant forms of that element found on Earth. An element's mass is listed as the average of all its isotopes on Earth. Now, Avogadro's constant. What do you mean by Avogadro's constant? Actually, Avogadro constant is a number of anything. Okay, so 1 mole of oxygen atom contain 6.022141179 into 10 to the power 23 oxygen atoms. Mind it, 6.022141179 into 10 to the power 23 oxygen atoms. Also, 1 mole of nitrogen atoms contain that 6.02 214,179 into 10 to the power 23 nitrogen atom. The number that is 6.02 to 14179 into 10 to the power 23 is called by the Avogadro number, by Na, Avogadro constant, or after the 19th century, the scientist Avogadro has invented this number, okay, has suggested this number rather. So each carbon 12 atom weigh about 1.99265 into 10 to the power minus 23 gram, okay. Therefore 1.99265 into 10 to the power minus 23 gram into the number, the total number of the atoms that we have, that is 6.022 14179 into 10 to the 23 atoms, and that is equals to 12 gram of the carbon. Okay, so this is the total concept of the mole and the Avogadro number and how they are connected with each other. Now number of moles, that is if we multiply this number of moles by the molar mass, by molecular mass, that we will get the mass in gram, okay. So so these are the some of the concept that we have. Now if we know now 1 mole of the substance, that means 1 mole of the substance, whatever is molar mass, molecular weight, that much gram will be present. Okay, 1 mole of the substance, that means the whatever the molecular weight of the substance, that much is gram is present. Now, 1 mole, that is equals to 6.02214179 into 10 to the power 23 number of atoms are there. Okay. Now, if anyone will tell you, ask you that how you can make the 1 molar solution. Okay, so how you can make like a 1 molar of the 1 molar of the H2SO4 solution. Okay, now what will happen for 1 molar solution? We have to take the molecular, whatever the molecular weight of the H2SO4, that much gram into 1 liter of the water. So if the molecular weight of the H2SO4 is 98, that means 98 gram of H2SO4 will be taken in 1 liter per 1000 ml of the water, and that the strength of that water, the solution will be 1 molar solution. Okay, solution of the H2SO4 will be 1 molar solution. So this is the concept of molarity. Now we will see what is the application of the mole. So application of the mole. Now the mass of the mole of a substance is called the molar mass of that substance. The molar mass is used to convert grams of a substance to moles. It is the element's atomic weight in gram per mole. If the mass of a substance is known, the number of moles of the substance can be calculated. Yeah. So converting the mass in grams of a substance to moles requires a conversion factor. Okay, the mole concept is also applicable to the composition of the chemical compounds. For instance, like CH4. That means this molecule is a molecular formula that indicates that per mole of the methane, 1 mole of the carbon and 4 moles of the hydrogen that we have in per mole in 1 mole of the methane gas. Okay, it can be related to the quantities like 1 mole equals to 6.0221414179 into 10 to the power 23 number of atoms. Yeah. So from this portion you can have so many types of numericals, that is very easy and important. Okay, so if you know how to calculate, how to solve that problem, you can very easily you can get the full marks. Yeah, the first question is, how many moles of potassium atoms are in 3.04 gram of pure potassium metal? Okay, now first of all you should remember what is the molecular weight or molar mass of the potassium atom. So the molecular weight of the potassium atom, actually that is 39.10. Okay, so as I told you, 1 mole of any substance, that is equals to whatever is molecular weight in gram. So 39.10, if the molecular weight of the potassium is 39.10 gram, that means 39.10 gram of potassium, that is equals to 1 mole of the potassium, right? Now we have, in our question we have 3.04 gram. So 3.04 gram of potassium means what? 0.0778 mole of the potassium. So if we are having the gram of substance, so very easily we can know how much molar, how many moles of that substance we have actual. Okay, so this is the by this you can solve this problem. Okay, now move to the next question, that is how many atoms are in a 3.5 gram of sample of sodium. Now again we have to first find out the molecular weight of sodium, and the molecular weight of sodium is, that is 22.98 gram. Yeah, so this much gram, that means this much gram sodium means again the 1 mole of sodium, right? 1 mole of sodium, whatever is molecular weight, that much gram will be present. So in our question we have 3.5 gram of sample of sodium. So 3.5 gram of sodium, that is equals to 0.152 mole of sodium. So first, if you have this type of question, first you have to convert this gram into mole. How many mole of the sodium is present? This 3.5 gram means how many mole? That is 0.152 mole of sodium. Now we know 1 mole equals to 6.02214179 10 to the power 23 number of atoms of sodium. So 0.152 mole of sodium means what? If 1 mole is this one, so 0.152 mole, that is equals to 9.15 into 10 to the power 22 atoms of the sodium. Okay, so this type of problems you may have in your exam from this portion. Okay, so you have to practice very well, and otherwise you can't understand how to solve the problem. The problems are very easy, only you have to remember some of the things, that is 1 mole equals to the whatever the substance, whatever the molecular weight of the substance, that much in gram. 1 mole equals to 6.02214179 into 10 to the 23 number of atoms of sodium. So all these things you should remember, so that time you can understand. Okay, so next we will discuss about the structure, atomic structure. Yeah, the atoms are generally made of the proton, electron and neutron, right? So what are what are their the arrangement, that now we will see. And also we will quickly just review the Rutherford atomic model and Bohr's atomic model. Okay, next, what is atom and what is the constituents of atoms? Yes, already you have read it. This is the basics of the chemistry. Okay, any compounds, any elements, generally first of all we should have the idea of the atom, right? So atoms are generally, there are two parts, one is nucleus, one is electrons. Okay, in nucleus generally, we know, in the atom, at the center of the nucleus, at the center of the atom we have the nucleus. Nucleus is generally, the constituents of the nucleus is generally neutron and proton. Okay, the mass of the proton is 1 mu, and charge generally we consider that is +1. For neutron, the charge is 0 and mass is 1 mu. Okay. For electrons, another part of the atom. So we consider that electrons are moving around the nucleus. Okay, we are having around the nucleus, we are having the the electrons, probability of finding electrons. Okay, so that we will discuss by Rutherford atomic model, by Bohr atomic model. Then after all we will discuss about the Sommerfeld atomic model. These are the some of the atomic model by which you can get the idea, actually, what are the components, constituents of the atom, and what is the arrangement of this nucleus and electrons. Okay, and what will be the energies. So the electronic cloud determines the size, volume of the atom, but does not significantly contribute to the mass. The mass of the electron is 0.0005 mu, very small particles, and charge generally we consider as the -1. Okay. Generally, the electrons determine the atomic number, and we are indicating this atomic number of any element, that is by Z. Okay, so this is the atomic structure. After the modified theory, we can know these are the atomic structure of these are the arrangement of the electrons, neutrons and protons. Generally, what will happen in the nucleus, we have the protons and neutrons, and around, and this is called nucleus. Okay, and around this nucleus, what the electrons will be revolving, will be moving, okay, moving around this nucleus. So this is overall atomic structure of our of any elements that we have in the periodic table. Okay, now Rutherford experiment. So what is Rutherford experiment? Actually, from the Rutherford experiment, we can know what are the arrangement of the nucleus, what are the arrangement of the electrons. All these things, for all these things, we have an idea. We can get an idea about the any atomic structure. Okay, so what he has done, this is a source of alpha particle. Okay, in his experiment, he what he has used polonium. Okay, so as a generator of the alpha particles. Generally, we know alpha particles. The symbol of the alpha particle is He plus 2. Okay, alpha particles, that is He plus 2. So this source is the generation of the alpha particle. Now this is a gold foil. Okay, this yellow color thin foil, that is called, that is the material the material of that foil, thin foil, is, that is gold foil. So in this thin foil is bombarded by the alpha particle. Okay, and this fluorescent screen, that is the actually he has used this fluorescent screen so that he can understand if the alpha particle will bombard will hit the gold foil, what will be the deflection of this alpha particle, how they are acting with this gold foil. For that, he has used this fluorescent screen. Okay. Okay, so what will happen while the alpha particle will hit this gold foil? What will happen? The maximum alpha particle, you can see the maximum alpha particle is passed straight through the gold foil. This is a gold foil and this is the alpha particle, and it can pass through the pass straight through the gold foil. Okay, this is the first observation. This was the first observation of his experiment. The second observation is very few alpha particle will be deflected. Okay, and very one or two alpha particle will reflect back 180 degree, right? So these are the some of the observations that we can get from the Rutherford experiment. And from his experiment, there are some of the consequence or conclusions that we can guess, or we can indicate that if the almost all the alpha particle will be what will be go straight through the gold foil, that means the maximum space of the atom will be vacant. So that's why the no deflection of the alpha particle, the alpha particle can pass through the gold foil straight. Okay, second one is the whatever alpha particle is reflected back 180 degree, whatever that means at the center of this the gold foil, there will be some heavy positive charge. For that, the alpha particle will be deflected back. Okay, so it will hit the positive charge, the heavy mass positive charge, and it will deflect it back. Okay, 180 degree. So that means that heavy positive charge, that heavy mass with the positive charge, that is called by the nucleus. Understand? So maximum space of the atom is vacant, and at the center of the atom we have some all the masses are masses we have for the atom, that is at the center. Okay, and the center, the nucleus, that is called by nucleus, and nucleus is positively charged, because that is why the alpha particle is also positively charged. That is why this alpha particle will be repulsion, due to the repulsive force it will reflect it back 180 degree. Understand? So this is the second conclusion. And third one, very few, you can see very few alpha particle will be deflected, so deflected or distorted from their path. So that means what? That means electrons, that means the around the nucleus the electrons are moving, and electrons are negatively charged, and helium is positively charged. That is why one interaction will be there, and that is why they are reflected, okay, or deflected from their straight path. So these are the some of the conclusions that we can make from the Rutherford model. That means I'm again repeating. So according to the Rutherford experiment, we can conclude that most of the spaces of the atoms are vacant. Second is, at the center of the atom we have positive charge, and all the masses are at the center of the atom. So that is called by nucleus, and electrons are revolving around the nucleus. Understand? So these are the some of the conclusions, some of the statements that we can get from the Rutherford experiment. That means a major fraction of alpha particles bombarded towards the gold sheet pass through it without any deflection. That is why all the maximum spaces of the atom is empty. Some of the alpha particles were deflected by the gold sheet by very small angles, and hence the positive charge in an atom is not uniformly distributed. The positive charge in an atom is concentrated in a very small volume, okay, and very few of the alpha particles were deflected back 180 degree. That is, only a very few alpha particles had nearly 180 degree angle of deflection. So the volume occupied by the positively charged particles in an atom at the center, okay. So these are the some of the statements that we can get from the Rutherford experiment about the atoms. Okay, so what are the limitations of Rutherford experiment? Okay, there are some of the limitations that we have. Like, according to the Maxwell, what will happen if one charged particle will be accelerated? Okay, will be accelerated. This particle will emit continuously some of the uh, electromagnetic radiations, like these electrons. Okay, this is one electron. This electron is revolving around the nucleus. This electron is charged, and nucleus is also positively charged. So according to the Maxwell, what will happen while the electron will be revolving around the nucleus? It will continuously emit some of the energy, electromagnetic radiation, okay, and hence the electron, what will happen after some time, the electron will loses energy, and once it will just collapse into the nucleus, okay. So hence an electron revolving around the nucleus should emit electromagnetic radiation, ultimately the electrons would collapse into in the nucleus. So all the electrons, what will happen, all the electrons will collapse into the nucleus, whatever electrons revolving around the nucleus. Okay, so this is, if we follow the Rutherford model, this case will take place. That means Rutherford model cannot explain the stability of an atom, because this is not the practical case. Generally the atoms are very much stable, so the electrons are not collapsing into the nucleus. So this is not the actual case, and this case is not explained by the Rutherford experiment. Okay, and one more thing, he did not say anything about the arrangement of electrons in an atom, which made his theory incomplete. And third thing is, he could not explain the line spectra of hydrogen atom. We are getting some of that we will discuss in our next we will discuss in the class, that what is line spectra of hydrogen atom. Okay, so that line spectra of hydrogen atom also cannot be explained by the Rutherford experiment. Okay, so these are the some of the limitations that we have for the Rutherford experiment or Rutherford atomic model. Next, to sort out this problem, to solve these limitations, next we have Bohr's atomic model. Okay, so according to the Bohr's atomic model, what will happen? The electrons are revolving a definite orbitals. Okay, a definite track. These electrons, all the electrons, whatever revolving around the nucleus, they are revolving at a definite track, and they have a definite specific angular momentum, that is mvr, that is equals to nh by 2 pi. According to his theory, the uh, according to this Bohr theory, always the electron, the angular momentum of the electron in a orbit which is revolving in a specific track, that is mvr equals to nh by 2 pi, and that is the specific one. Second statement is, Bohr has stated that electrons are not emitting the energy continuously, only when the electron will change its track. Either it will go towards the lower energy level or higher energy level. That time only the electron will emit some energy or absorb some of the energy. Otherwise, the radiation continuous. According to the Maxwell theory, the electrons should continuously radiated. So that is not actually the case. While the electrons are revolving around the specific track, the angular momentum is specific, constant, and while it will change the track, only that time the what will happen, only that time the energy will change, energy will transfer, or energy will be absorbed. Okay, so okay, so if the electron will go towards the lower energy level, it will emit some of the energy, and that is E. Okay. So electrons revolve around the nucleus in a fixed circular path, that is termed orbit. Okay, the orbits are termed as stationary orbit. Yeah, the orbits, all orbits are the stationary orbit. Okay, the different energy levels, whatever the different energy levels but different stationary orbits the Bohr has suggested, he has denoted as the quantum number, that is called principal quantum number, and that is n. n equals to 1, n equals to 2, n equals to 3. Like this way, the n value will increase. Okay. The different energy levels are denoted by the integers such as n equals to 1, 2, 3 and so on. These are called principal quantum numbers. The change in energy occurs when the electrons jump over from one energy level to another energy level, as I told you. Okay. So, okay, so thus Bohr can solve the problem of the atomic stability, which we which we cannot explain with the Rutherford atomic model, but thus the atom, only the electron will emit the energy or absorb the energy, while it will change the orbits, the energy levels. Okay, so this will exactly this will sort out the problem of atomic stability. And whatever energy and also Rutherford cannot explain the line spectra of hydrogen atom, and according to the Bohr's theory, whatever energy is emitting, that energy, due to that energy, emission of that energy or absorption of that energy, we are getting the line spectra of the hydrogen atom. So these statement, the hydrogen line spectra of hydrogen also can be explained by the Bohr's theory. Now we have to derive, this type of questions are very common, that we have to derive the radius of first orbit of hydrogen atom. So in your exam, this type of question are very commonly you can have. Okay, so derive the first orbit of hydrogen atom, and based on that equation also you can have some of the problems, you have to solve some of the problems. So that also we will see how to solve the problems with the help of this equation, that we will see in the next. Okay, so while the electrons are revolving around the nucleus, what will happen? The electrons having two type of force. Okay, one is centrifugal force and second one is centripetal force. Okay, so the movement of the electron in its orbit would create a centrifugal force. So this centrifugal force we can explain like this. We can write down the expression of this centrifugal force as equals to minus mv square by r. Now, centrifugal force was exactly matched by the opposite centripetal force, and that is why the electrons are stable at its orbit. Okay, continuously revolving around the nucleus, while the centrifugal force and the centripetal force will be similar, will be same. Okay, now this Coulombic force is that is z square by r square. Okay, minus z square by r square. Okay, so mv square by r, that is equals to z square by r square, right? Okay, next that means r equals to mv square r square by z square. So if we multiply the right side of the equation by m by m, so if we multiply this right side equation with the m by m, what will happen? You can see r equals to, we can write down mvr whole square. that is divided by mz square. Okay. So according to the Bohr's model, what will happen? Look, this mvr, that is angular momentum, as I told you, mvr angular momentum of the electron, that is equals to nh by 2 pi. So if we put here this mvr value here in this equation, if we put this nh by 2 pi value in this equation, what will happen? R equals to n square a square by 4 pi square mz square. Okay, so now let me tell you all the all the parameters. Yes, n is the, you know already, the energy levels. H is the Planck constant. Okay, now pi is again a constant. M is the mass of the electron. Z, what is Z? Z is the atomic number, and E is the charge of the electron. Okay, so all these are the parameters. Now for hydrogen atom, what will happen? Z equals to 1, we all know. The smallest radius, that is smallest radius, is obtained from equation 1. So if we put here z equals to 1 in this equation, what we will get? And for hydrogen also n equals to 1. So what we will get? That is A0, the smallest radius, that is indicated by the A0. Okay, so that is A square. As n equals to 1 and z equals to 1, we have put these values. So a square by 4 pi square m e to the power e square. Okay, which is 0.529 angstrom. Because all these parameters are known, the Planck constant, the pi value, the mass of the electron, the charge of the electron, all these values we know. So if we calculate by putting all these values, we can know the radius of the hydrogen atom, that is 0.529 angstrom. Okay. So that means if we put this A0 value, in this equation, number 1, what we will get? We will get R equals to n square A0. A0, what is the value of A0? That is 0.529 angstrom divided by Z. Okay. So for any atom, we can get the radius, atomic radius. Okay. So thus this is the derivation of radius of first orbit of hydrogen atom, and by using this equation also we can get the other elements radius also. Okay, so now you can see, look here, the R is directly proportional to the n square, directly proportional to the quantum number n, the energy levels. Okay, so direct proportional to the square of the quantum number. So quantum number, if quantum number increases, so radius will increase. Quantum number decreases, so radius will decrease. Understand? So this derivation is very important. You can have this type of derivation in your exam, so you have to practice well. Understand? Okay, next we will see how we can derive the energy of the electron revolving in first orbit of the hydrogen atom. So now we will see the energy of the electron. Okay. So the total energy of the electron is can given by kinetic energy and potential energy. We all know that for energy of an electron, always it is the summation of kinetic energy and the potential energy. So kinetic energy means what? Exactly, that is half mv square, and the potential energy, that is minus z square by r. Okay, so we know that v square equals to minus z square by mr. Okay, from the Bohr orbital, the derivation of the Bohr's orbital, already we have seen that v square equals to minus z square by mr. So if we put this value in this equation, what we will get? That means En equals to what? Half m z square by mr, right? Yes, minus z square by r. Okay, okay. Yes, now what we will get? Minus z square by 2 into 4 pi square mz square by n square a square, and our final equation will be this one. En equals to minus 2 pi square mz square e to the power 4 divided by n square a square. While where you all know that En money, that means energy of the electron, pi equals to constant, m is the mass of the electron, z is the atomic number, E is the charge of the electron, n is the quantum number, and h is the, that is Planck constant. Okay, so for hydrogen atom, what will happen? N equals to 1 and Z equals to 1. So put these values into this equation number 2. What we will get? If Z equals to 1, N equals to 1, we will get minus 2 pi square m e to the power 4 by a square, right? Sorry. Yes. Okay. So this is the final equation that already we have seen. Sorry. Yeah. Okay, so En equals to that is energy of the electron, and R equals to that is n square a square divided by 4 pi square n z square, and En, that is equals to minus 2 pi square mz square by, yes. Hmm. So En equals to, okay, so this is the energy. Energy equals to 2 pi square mz square e to the power 4 divided by n square a square. This is the total whole equation of the Bohr orbit and also the energy of the electron. Okay, now we will calculate the radius of the first orbit of the determination of the first orbit of hydrogen atom. Already we have seen. Okay, now look, so R equals to, yes, what is happening? R equals to, this is the radius, N can be 1, 2, 3, H is the Planck constant, that is 6.626 into 10 to the power minus 27 R per second. M is the mass of the electron, and which is 9 into 9.1 into 10 to the power minus 28 gram. E equals to, you know, ki charge of the electron, that is 4.8 into 10 to the power minus 10 ESU. Z is the atomic number, and pi is the 3.14. That all we know. Okay. So what will be the next? So energy of the nth bore's orbit, that is equals to, already we know the equation. Actually it should be the radius. Okay, next. Yes. So the R1, this is not the energy, this is the determination. Look at the question. That is determination of the radius of first orbit hydrogen atom. Okay. So this is not the energy calculation. Yes. So R1 equals to n square a square by 4 pi square mz e square. This is the equation. So if we put all the values, what will happen? We will get the value, that is 0.59 into 10 to the minus 8 centimeter, which is in angstrom. We can write down that is 0.53 angstrom. Okay, understand? Okay, next we will see what is the next. Yeah, sorry. If the energy of the first Bohr orbit is 13.58 electron volt, what will be the energy of the third Bohr's orbit? Okay, now here we know the we have to calculate the energy of the Bohr's orbit, that is third Bohr orbit. Okay, so while you are solving the problems, you have to check the question very well. First, you have to determine the energy of the first Bohr orbit, the electrons of the first Bohr orbit, or you have to determine the energy of the third Bohr orbit. That you have to check very well. So all these things you know, that is R is the radius, N is the 1 2 3, that is the quantum number, H is the Planck constant, that is 6.623 6 into 10 to the minus 27 R second. M is the mass of the electron, that is 9.1 into 10 to the power minus 28 gram. E is the charge of the electron, that is 4.8 into 10 to the minus 10 ESU. Z is the atomic number, and pi, the value of pi all we know, that is 3.14. And also we know the E1, that is the energy. What is the energy expression for the E1 for hydrogen atom? That is minus 2 pi square m e to the power 4 by a square. So hence E3 equals to minus 2 pi square m e to the power 4 by 3 square n square a square, because this is n equals to, here n equals to 3. Okay, not 1. So that is why we have put here the 3 value. Okay, n square a square, that means 3 square a square, that means E3. E3 means the energy of the orbit 3, or E1, the energy of the first orbit, that is E3 by E1, that is equals to 19. So 19 into E1 value already we have already derived, that is 13.58 electron volt. So if we can multiply with this with 1 by 9, so that will give you minus 1.509 electron volt. So this is the third energy of the third orbit. Okay, so if you have this type of question, thus you can solve, because first of all you should memorize ki, remember what will be the equation for the energy equation. Okay, and after that for hydrogen first orbit, what is the equation? That is E1. After getting E1, also you can solve the problem of E3, that is the energy of the third orbit. Okay, Okay, next we will see. Okay, now you know the about the atomic arrangement, the atomic structure, the Rutherford atomic model, the drawbacks of Rutherford atomic model. Now, for to sort out that Rutherford atomic drawbacks of the Rutherford atomic model, we have the Bohr's atomic model, and also we are having some of the drawbacks for the Bohr's atomic model. So all this you have seen. Now I have given one question for a quick review. Whatever you have, you can understand from this chapter. So the question is, 1 mole equals to how much? Okay. So for this you will get the 10-second time. Your time starts now. Whatever I have discussed, that you have to remember to answer this question. Okay, now your time is over, and you're absolutely right. The answer is 1 mole equals to actually the Avogadro number, that is 6.022141179 into 10 to the power 23. Okay, so this is the correct answer. Now this is the recapitulation whatever we have discussed today, that is the Avogadro number we have discussed, the mole concept, some of the simple numerical problems also we have seen how to solve that problems. And just quickly we have reviewed that the Rutherford atomic model, the Bohr's atomic model, and the drawbacks of that atomic model. Okay, yeah, so this all are checked. So students, please follow the classes regularly, and I have given one assignment also, so just submit the assignment in time, and see you in the next class. So thank you, students.